Hi everyone, welcome back to my channel. So in today's channel we are going to discuss about enumeration methods. So in the previous sessions I have already discussed about what is enum and what is the need of enum in system Verilog. So as you already know that enum is used in order to create user defined data types also. Okay, so just like if you have seen in queues and in arrays you are having various methods in order to access all these array elements or else anything. Okay, just like that, in order to access the enumerated elements you are having certain methods in enumeration. Okay, so if you see these methods you are familiar with all these methods in arrays also. Okay, so the working is same in both arrays as well as in enumerated data type also. So but these are certain methods that you can use in enumeration. The first thing is first, last, next. Okay, next, and within next you will be having element also, nth member. That means based on the pointer you can do it, or based on the particular element. If you want to see what is the next element of this particular element, then you can do that also. Okay, and then previous, again previous, and number, name. So if you see all these methods, these are mostly used in many arrays also. Like in queues you have seen all these things, and in associative arrays, dynamic arrays. Okay, so in all these arrays you have seen that. Okay, so I don't want to particularly explain about all these methods since you already know it, right? So here this is the example of this enum. Okay, so what I'm doing is I'll just pause for a second. You can just take the screenshot of this and you can just analyze the example that I have shown here. And if you are having any doubts in this example, you can comment me in the ping box. I will definitely answer you. Okay, and in order to know about all these methods, you can go check it in the arrays methods. Okay, I have explained clearly about all the methods in arrays. Okay, I'll link that in the description box. You can go check it out. I have created a separate playlist for arrays. If you are new, I'm just telling that I have created a special playlist for arrays. You can, I'll link that in the description box. You can go check it out there. Also, if you are new to my channel, consider subscribing my channel. Also, many of you are watching this channel without subscribing my channel, but if you are a VLSI enthusiast and if you are interested in this course, please do subscribe my channel and then move forward in my journey of sharing my knowledge and views on this particular course. Okay, right? So this is about enum. Hope you have taken the screenshot of this particular example, right? So this is another example. Like if you see here, this is just a basic example on all the methods. Okay, by using the loops you can write the enum by using loops also. This is one more example for that. Okay, so you can just screenshot this. I think I don't need to explain this, because by seeing this you can understand that what I have done here. I have just user defined the enum, and I have taken a pkt type as my variable, okay, as my data type. So this is my user defined data type. By taking this user defined data type, I have created two variables, pkta and pktb. Now if you see here, if you have listened to my enumeration data type, why, what is the need of enum data type, you will understand about all this program. Okay, I link that in the description box. You can go there, check it out. So here this both packet a and packet b can hold two values. What are those? It can hold either good or bad. Okay, so based on the thing, I have just written a program, right? So this is all about arrays. Now we are going to another topic, which is structures and unions. Okay, structures and unions you mostly don't observe in many of the Verilog codes you are seeing in system Verilog or system Verilog, but these are important based on their usage. So basically what is structure means, in simple language, it is similar to array. Okay, so actually what does the array do? Array means collection of elements, is it or not, right? So what I am telling is, for example, if you are taking an array, Okay, if you are taking an array, some array of 5. Now what you are doing, you are taking some 5 elements like 1, 2, 3, 4, 5. Okay, so for example, let us consider this is int data type. Okay, so int array of 5, 1, 2, 3, 4, 5, right? So if you see here, array is nothing but collection of elements. That means if you want to group some particular elements, if you want to take the not individual elements but you want to take it in the form of group, then you go for arrays. Is it or not? But if you see here, in arrays, all this like 1, 2, 3, 4, 5, all this belong to integer data type only. Is it or not? That means what I am telling is you can't take it like this, like 1, 2, okay, some sit, some 4, some stand. Okay, if you are taking it like this, it will throw you error. Why? Because array is collection of variables. Though it is a collection of variables, it is collection of similar data type variables. Okay, but when it comes to struct is the collection of group of data types. Okay, just like array is collection of elements, similarly structure is collection of different data types. That means if you want to take various data types but it in a packed format, okay, that means if whenever you are calling this particular thing, all the data types that you have taken in that particular element all should come in a packed format, like in there they should be grouped together. So when you want to make some different data types to group in one format, then we will be using this structure. Okay, hope you understand what is structure means. So if you see here, structure is collection of elements having different data types. That is different from array. Okay, this is why array is different from structure in this way. Though it is a collection of elements, array is collection of similar data types, whereas structure is a collection of different data types. You should remember this, because mostly if anyone asks you in internship, they will be any interviews, they will asking you what is the difference between array and structure. So both are for grouping the elements, but array is for grouping similar elements, whereas structure is for grouping different elements. So we will see how are we going to collect all these different data types. These elements can be accessed as a whole or individually. So basically whenever we are accessing any data type, we will be accessing it individually. Like what I am telling is, for example, okay, for example, if you are taking some three different kinds of data types, like one is int a, okay, another is string name, okay, another is float or real, anything, real b. Okay, so whenever I am accessing a, I should access it as a individual, I should access it individually. So whenever I am calling a, only a will be coming based on this particular data type. Is it or not? But if I want to access all these elements in a single way, by using the single handle, if I want to call all these things, is it possible? No. If we are not using structures, it is not possible. But we are using structures, it is possible to access all these data types by using a single handle. Okay, that is the advantage of this structure, right? Let us see how we are doing this. And also one more thing is, you already know that in enums I have told you that enum is a special data type which can be used to create user defined data types. Is it or not? So similarly structures and unions also is used in order to create user defined data type. Okay, similar to enum only, just like in enum how we will be using a type def keyword in order to create a data type. Similarly in structures and unions also you will be using a type def keyword in order to create any user defined data type. Okay, now let us see the syntax of how we are going to write the structure. Okay, when you are writing a structure, that means when you want to group different data types together, you should do it by using a keyword named struct, struct. Okay, struct, and you should be followed with it should be followed with a flower brace. Okay, within this flower brace, if you want any data type you want to mention, you can mention it. Just like if you see here int string real, so all these data types you can mention this here, and then you can close this. That means this is the thing that all these data types are packed in one struct. Okay, so after ending you have to give the structure name. So basically this is somewhat different. So until now what you have learnt in this course, as soon as you are giving the keyword, you are mentioning the name, but in the structure you should mention the name after the ending of this flower braces. Okay, struct name. Now let us see an example for it. So when you are creating a normal array, how you are going to create it? Int array of 10, or if you want to create some memory, okay, then it is some 256, which where each element can hold 8 bits. Okay, so all these are either this, if you see this here, all these elements are int data type, and all these elements, 256 elements, are bits. Okay, now if you want to access this array, you can access this it in a int format by using this array handle only. And now if you want to use this memory, you should handle it by using this memory handle. Okay, but when you want to access both of these things at the same time, you can do this by writing it in this manner. Like if you see struct, okay, flower brace open. Now I am taking three variables like value 1, value 2, value 3. So these are my three variables, and all three variables are having three different data types. So value 1 is of byte data type, value 2 is of int data type, value 3 is of string data type. Okay, now after writing all these elements in one struct, I am ending it by writing a struct name. Struct name can be any individual name. You can write it any, like struct1 or anything, you can write it. Now this is how you are going to write a struct. This is how the syntax is for the structure in system verilog. Okay, so let us see a small example for this, like where do we use this structure. As I told you, we will be using, if we want to handle all the group of different data types at one place, we will be using struct. So will there be any case where we need to use it? Okay, any practical case? Yes, there is. So if you see the example here, okay, module struct. Okay, this is my module, and within module I am writing a struct. If you see here, struct. Okay, I am taking three data types. If you see here, one is string, another is bit, which is of 32 bits, okay, which is 32-bit size, and then integer id. Okay, and then I have ended my struct, and I have named my struct as employee. Okay, so this is my handle. If you see, now whenever I want to access all these elements, I can access with my single handle employee. Okay, let us see how we are doing this. Initial begin. Now if you see, I want to enter something into this name, I want to enter something into the salary and id. How can I do? Just by taking employee dot name. That means this is the handle of my structure. So that handle of my structure dot the name of that particular variable. Okay, the variable here, if you see, employee dot name equal to, I'll just, since this is of string data type, I can write name. Okay, employee dot salary. Okay, since it is of 32 bits, so tick h 1 4 zeros. Now employee dot id, it is of integer data type, so tick d 1 2 3 4. Now I want to display all my employee data here. So if you see here, whenever you are creating, okay, whenever you want to access these elements individually, how can you do it? Instead of doing all these things, you should write name, okay, and you should enter something, and salary you should enter something, employee id you should enter something, and then whenever you want to display it, what you should do? You should just display name equal to percentage d and salary equal to percentage d. So in this way you have to display. So whenever you want to access something, you have to access it by its individual name. But when it comes to structure, what you are doing, just you are writing employee, so it will be displayed. That's it. If you see here, employee name, salary, id. Okay, dot name, dot salary, dot id. Even though you are doing this, the same is applying. Even though you are writing it in this display, the same thing will be employed. Okay, if you want to access any individual struct member, that means whenever you are typing employee here, all the data, that is all the data types that you are using within the structure. That means the entire package structure will be displayed. But if you want to use that individual struct, you can do this in this way also. Like if you want to display only particular thing in that, if you want to only display salary, then you can do it by using the handle dot name, handle dot salary, any variable that you have mentioned in your struct. Got my point? So this is how. Now there is one more advantage in this struct. What is it? If you see here, I have taken, now if you see, since I'm taking one handle here, it can be used for only one. For example, if we are considering about okay, let us consider if we are making a marks list of any student or else something. Okay, in the class if we are having some 20 students, and if you want to analyze all the data of that student, okay, all the students data, then how can you do it? Okay, by using struct you can do it. But if you see, I am using only one handle here, so I can handle only one person's data here. But if we want to handle all the 20 students data, can we do it? Yes, we can do it. Now if you see here, okay, the same thing here, what I have done is I have taken the type def struct. Okay, so yes, if you see here, this is my type def struct. Okay, so in this type def struct, so you already know that if we are using a type def struct, then that means you can use it as a user defined data type. So the same thing, just like you are using the type def enum, similar thing here also, type def struct, and whatever you want to create you can create with again the same thing, the same example, employee. Now what happens, this employee is a data type. Okay, just like your string, bit, integer is a data type, similarly employee is also a data type. Now with employee I am taking another two variables, e1 comma e2. Now what I am doing, say what can this employee handle? Employee can handle name, salary, id. Okay, so with these two handles I am creating data for two students, two employees, like e1 dot name alex 1000 1234. So this is created by, this will be entering into e1 memory. Okay, and then this will be entering into e2 memory handle. Okay, so in this way, how many employee, for how many students or how many employees you want to create, you can create it in this way. Okay, now simply by taking e1 e2 you can just write it. Okay, but if you want to only, if you see here, if you want to access any individual structure member, you can do it with what, e1 dot name, e1 dot salary, e1 dot id. Clear? So in this way, by using a single program, you can handle all the names. This is possible in case of structure. Okay, hope you understand what is structure. Right, if you see here, see, module structure, type of structure, the same example for students here, int string. So I have packed all these things with the student. Now since this is type def, so this student is a data type, it is having two handles, s1 s2. So with s1 I have created a individual data for particular student named Amit, and with, now what I'm doing, I'm copying, I'm not creating anything for s2, but I'm copying everything from s1 to s2. So whatever that is there in s1, it is copied to s2. If you see here, this is my s1. Okay, and since I didn't create any memory at the starting, s2 is here, but after copying, because if you see here, I have just entered only for s1, but I have displayed for s1 and s2, so the s2 value is all 0 here. But in the second case, I have copied everything in s1 to s2, so whatever that is there in s1, it will be in s2 also. See, now after this I have changed only one particular element in s1. See, s1 dot Anita. Okay, so now what happens, the name will be changed from Amit to Anita. Okay, now if you type the same program in EDA playground and if you check out, okay, now s2 will be the same as this one. Okay, only there will be change in s1. Okay, right, hope you got it clear. So this is about structure in System Verilog. Okay, in the next class we will be seeing about again structure is classified into two types like packed and unpacked structures. Okay, we will be seeing what is the difference between this packed and unpacked structures. Hope you understand about this. If you like my channel, please give it a like and also follow me on LinkedIn for further updates. Thank you.